focus question for today is, how can I use proportions to solve triangle problems? Using proportions to solve triangle problems. Alright, on page 490 is the triangle proportionality theorem. And it says if a line is parallel to one side of a triangle, if a line is parallel to one side of a triangle, and intersects the other two sides, then it divides the sides proportionally. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. And then here's a picture of what that means. If you got a triangle, if a line is parallel to one side of a triangle and intersects the other two sides, so add a line, make it parallel to one side and intersect the other two sides. So now it's parallel, because we're saying it's parallel, and it's intersecting the other two sides. Then the rule says it divides the sides proportionally. So this segment BE divides side AC of the big triangle and side AD into proportional pieces. It means that this segment AB over segment BC is going to be equal to segment AE over what? ED. Good. Okay. This piece, A to B over B to C, is equal to A to E over E to D. And if you're given values, you can substitute the values, you can crisscross multiply, and you can solve for the missing piece. So if this is a 6, and this is a, I don't know, a 2, and this is 8 and a variable, then your 6 over 2 equals 8 over x. And just like you did last week, you crisscross multiply and you solve. So 6 times x is 6x. 2 times 8 is 16, divide by 6, and x equals 2.67. Any questions there? The converse to that statement is on the next page, but let's just, you don't need to do all that writing. Here's the second part of this theorem that you want to understand. If you're given this picture, and now you're given the information, let's call this one ABC. All right, let's say this is the diagram now, and this is 10, and this is 5. That's not 5. Let's go 10, 4, 20, and this is, say it's 8. Okay, obviously it's not to scale. And you're asked, is BC parallel to DE? Okay? So this is the converse of what we just talked about. Well, if 10 over 4 equals 20 over 8, then doesn't BC divide these sides proportionally? Okay? And if BC divides the sides proportionally, then it's parallel to DE. Okay? So does 10 over 4 equal 20 over 8? Good, it does, because 10 is half of 20, 4 is half of 8. So, is BC parallel to DE? Yes, it is. Alright? Because the sides are divided proportionally. Now, if this 8 down here is no longer an 8, and all of a sudden it's a 7, now is BC parallel to DE? Yeah, now it's not, because 10 over 4 does not equal 20 over 7. Okay? Triangle proportionality theorem. Any questions there? Look at the bottom of page 491, the triangle midsegment theorem. The midsegment theorem. A midsegment of a triangle is parallel to one side and half that side's length. A midsegment of a triangle is parallel to one side and 1/2 that side's length. So if you take a triangle, a midsegment connects midpoints. So if AB is congruent to BD, and AC is congruent to CE, then B is a midpoint and C is a midpoint. And a segment that connects two midpoints is called a midsegment. A midsegment of a triangle is parallel to one side and half that side's length. So BC is parallel to DE. And if the length of BC is equal to 10, what is the length of D to E? parallel to one side and half that side's length. It's 20. Good. Okay, it's 20. The midsegment is parallel to a side. It's parallel to this side, DE, and it's half of its length. If this right here was 3y, and this right here was 1/2 y plus 20, how could you solve for y? If this piece A to B is 3y, and B to D is 1/2 y plus 20. Good, you could make 3y equal to 1/2 y plus 20. And then subtract 1/2 y from each side and divide by 2.5. Look at page 492. Proportional parts of parallel lines. If 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. And this is really just an extension of the first theorem that we talked about. All right, in that first theorem, you know, we said if you had a triangle and if there's a segment parallel to one of the sides, then it intersects the other two sides, then the pieces are split up proportionally, okay? If this was A, B, C, and D and E. Okay, we said that AB over BD equals AC over CE, if that's parallel. Okay? If you take that same concept and just expand it a little bit, all right, this says if 3 or more parallel lines intersect two transversals. Well, here, if you got 3 or more parallel lines, if you do something like this, here's 3 parallel lines, okay? And they're parallel because we say so. They're all parallel to each other. And they intersect two transversals. If they intersect two transversals, well, this could be a transversal. And now this can be a transversal. Do you see how the pictures are similar? But your picture that you may get may look like this. The transversal may be here and over here. Okay? But the same rules apply as a segment parallel to the side of a triangle. All of these pieces here are proportional. If this is ABC and this is DEF, alright, then this piece right here, AB, over BC, is going to be equal to this piece, DE, over E to F. Okay? This piece over this piece is going to be equal to this piece over this piece. When three lines are parallel, three or more parallel lines intersect two transversals. Any questions there? Alrighty then, your assignment for today